Hello. Yes, we welcome you back to PSSB, Physical Sciences, Silver Bullet, and it's me, Richard, here. Okay. Yes, we are looking at the question. It says that structural isomers are categorized into several types, which include position isomers, chain isomers, and function isomers. And the question says that define each of the following and give examples. The first one is functional isomers. What are they? So functional isomers are compounds with the same molecular formula but different functional groups. They belong to different homologous series but having the same molecular formula. So let us look at some examples here. So yes, the examples. Suppose you have this one as our molecular formula. Yes, that one. We can get two compounds. The first one, we can have CH3, CH2, CH2. So these are 3 carbon atoms. Then the fourth one can be like this. Yes. Okay. We can also have another one. What is it? CH3. We can have that carbonyl there. Then CH2 and CH3. Now, if you look at these two compounds, this is what we are going to realize. First of all, they belong to different homologous series. Let us look at the name of this one. So what is this one going to be? We are going to say 1, 2, 3, 4. So it is a butanol. Okay. Let us come here. Yes, we can also try naming. So the number is 1, 2, 3, 4. You have to know that this number does not have any other alternative, so you can ignore it and just say butanone. Yeah, some people would want to call it 2-butanone. It doesn't make any difference. Okay, but I want you to tell you something, that butanone is a ketone and butanol is an aldehyde. These two compounds are belonging to different homologous series. But guess what? They have the same molecular formula. So, because they have the same molecular formula and belong to different functional groups, they are functional isomers. So, let us look at another example. Suppose we have this one as our molecular formula, C3H6O2. Look, I want to give you a tip. The moment you see O2, you expect two homologous series which are having 2 oxygen atoms within their molecules. Here, you are expecting those compounds which are having 1 oxygen within their molecules. So the question here is that, what are those homologous series which are having two oxygens within their molecules, two oxygen atoms within their molecules. Okay, one, we can have a carboxylic acid. So we can say CH3 and CH2 and C. Yes. When you look at this compound, it has this one as the molecular formula. There are 3 carbon atoms, 6 hydrogen, 2 oxygen. Okay, we can have another one. We can have another one which is CH3, C double bond, or then we'll have that one. Yes, that is it. Now, if you look at this compound, let us try to name it. It is a carboxylic acid with 3 carbon atoms. So it's what? Propanoic acid. If naming is to go by, you don't forget that for terminal, this is another functional group which is terminal. This one is number 1, number 2, number 3. So it's propanoic acid. So let us go to this side. This side, we are having this ester link within the molecule. So this is an ester. And if you decide to name, you'll have to cut here. And after cutting there, you have this side as our methyl. And this side as our ethanoate. So what do we do? To get the name, you combine these two, but you have to know that the name starts with an alkyl group, so it starts with methyl. So what is the name? The name is methyl ethanoate. And that is that. But you have to remember that propanoic acid belongs to a carboxylic acid and methyl ethanoate belongs to esters. So these two compounds, they belong to different homologous series. They have different functional groups. But guess what? They have the same molecular formula. So these compounds are functional isomers because they have different functional groups. And with that, would like to thank you for your time. The channel is PSSB, Physical Sciences, Silver Bullet, and it's me, Richard, here. Yes, we are not going to get tired of reminding you to subscribe, to share, to like, to comment. Yeah, stick with us. We believe we are simply the best. See you next time. Bye bye.